Okay, in this section, we're going to look at measures of location. The common measures of location are quartiles and percentiles. A percentile tells us the percent of data that fall at or below that value. So some common percentiles you might be familiar with if you recently took the ACT. If you scored in the 85th percentile, that doesn't mean that you received an 85% on the exam, on the ACT test. It means that you scored better than 85% of everybody else who took it. So other places are like growth charts. If your child's in the 40th percentile, it just means they're bigger than 40% of the people in their age. So quartiles are percentiles that break our data into fours. So the first quartile is the 25th percentile. The second quartile is called the median or the middle data value, and that's also the 50th percentile. So it divides your data exactly in half. And the third quartile, Q3, is the 75th percentile. So we use the first and third quartiles to calculate what's called the interquartile range, and that's just the range of the middle 50% of our data. And it helps us, one thing this helps us with is to identify potential outliers. So if we calculate their interquartile range, multiply it by 1.5, and subtract that from the first quartile, if there's a data value below that, then it's considered an outlier. If we, after we multiply it, add it to the third quartile and there's a data value above that, that is also considered an outlier. Okay, so we want to look at an example. I'm going to actually come back to this one. We're going to go down to look at this one that's grouped together. We have 50 statistics students who were asked how much sleep they get per school night, rounded to the nearest hour. And here's the result. So 4 hours per night, sleep per night, which is not much, was 2 students. Remember how we calculate the relative frequency? We take 2 and divide it by the number of students we had, 50, and that's how we got our 0.04. And then cumulative relative frequency, we're just adding it up. Okay, so one thing we can think about this cumulative frequency is, think of it as a percent. 4% of the students were 4 hours or less. Okay, and the reason I say or less, because when we look at the second one, here's 5 hours of sleep. There were 5 students that said they got 5 hours of sleep per night. So we take 5 divided by 50, and that gives us our 0.1. That means 10% of the students got 5 hours of sleep. And then the cumulative is we just add these two together. So this means 14% of the students got 5 hours of sleep or less. Does that make sense? So then here, for 6 hours of sleep, there were 7 students that got 6 hours of sleep. 7 divided by 50 is 0.14. Okay, and the 0.28 is then we add these three together. That means 28% of the students got 6 hours of sleep or less. I'll understand. So the last cumulative relative frequency is 100, which means 100% of the students got 10 hours or less of those 50 students, and these will add up to 50. So when we're looking at a table like this that has our cumulative relative frequency, we can use that to get our percentiles. So find the 28th percentile. So we can see here in this third row, the cumulative relative frequency is 28%, which means 28% of the students got 6 hours or less. So our 6th percentile is 6 hours. Make sense? All right, same thing we can do for find the 80th percentile. We just look at our cumulative. The cumulative relative frequency is going to be used to look at your percentiles. So here we have 80%. So this means 80% of the students got 8 hours or less. Okay? All right, what about the 90th percentile? Now this one's a little bit different because we have 80% got 8 hours or less and 94% got 9 hours or less. So because there were 7 students who got 9 hours, the 90% is going to fall in this category. So our 90 percentile is 9 hours. Okay? All right, what's the first quartile? So another name for the first quartile, remember, is the 25th percentile. So if we look back up here at our chart, we know that 6 hours, there were 7 students that had 6 hours of sleep. That was the 28th percentile. And 5 students had 5 hours sleep. That was the 14%. So because our 25th percent is higher than the 14 but lower than the 28, that means it falls in this category here with 6 hours. So that means 6 hours is also our 25th percentile. Make sense? Okay, so if we're finding it directly from our set of numbers, the 70th percentile, if we have a whole number here, for example, 50, we can usually just multiply it. However, with some different sample sizes, there is a formula to find the place value of the 70th percentile. So I is actually the position. And the formula that our text uses is K over 100, and K is our percentile, times n plus 1. So to find the position of the 70th percentile, we would take 70 over 100, which is 0.7, times n plus 1. So this would be times 30. And that would give us 21. So the 21st position is our 70th percentile. So we count to 20. These data are already in order. So you do want to remember when you're doing percentiles to put your data in order. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So our 70th percentile is 64. 64 years old, because these are ages for Academy Award winning Best Actors. So 64 years. Okay, so let's do the same thing for the 83rd percentile. So we have 83 over 100 times 30. Let's look at our calculator here. We do 0.83 times 30. Okay, now on this one, we get 24.9, right? Okay, so when it falls in between those two, that's in between the 24th and 25th position, right? 24.9. So this is 21, 22, 23, 24. So this is the 24th and this is the 25th. So what we're going to do is just average those. What's halfway between 71 and 72? That's right, 71.5 years. All right, let's find the first and third quartile, and then we'll find the interquartile range. So the first quartile, remember, is the 25th percentile. So we do 25 over 100 times 30. And then for the third quarter, it's the 75th percentile. So we do 75 over 100 times 30. Okay, so for the first quartile, we got 7.5. So we're going to count 1, 2, 3, 4, 5, 6, 7. So that one's in between 29 and 30, right? So the first quartile is 29.5. And then the third quartile, we got 22.5. So 22 and 23 are 67 and 69. Halfway between them is 68, right? So the interquartile range then is 68 minus 29.5. Okay, so let's go back over to my calculator here. Sorry about that. 68 minus 29.5. We get 38.5. Okay? Now, I don't have on here checking for outliers. Oh, I do say, are there any outliers? So this is a little tricky. I'm not sure if they have this in your homework or not. I'm thinking they don't, but I'll show you anyway. If we do 1.5 times 38.5, remember this formula back up here? We're going to multiply that interquartile range times 0.5. So we get, I'm sorry, I didn't realize you couldn't see my screen here. $19.25. And basically we're going to take Q1 plus 19.25 and Q3, minus, and Q3. Oops, sorry about that. Q1 minus 19.25 and Q3 plus 19.25. And then we do 29.5 minus 19.25, and we get 10.25. So basically what we're looking at in our data now is, are any of the values lower than this or higher than this? So anybody younger than 10.25? No. Older than 87.25? No. So there are no outliers. That's a little tricky, so if you get one of those and you want to do some office hours to kind of go over it, make sure you got it, just let me know, okay? All right. Okay, now in this section, we're also dealing with measures of location, but we draw another technique from exploratory data analysis, which is similar to the stem and leaf display, or stem plot. And this is called the box and whisker plot. And we can either draw it horizontally or vertically. We're going to draw it horizontally here. But we are going to use our calculator to help us here. So I want to show you a couple things with the calculator that I referred to before. The calculator will help us get this, but we draw this box and whisker plot from what's called a 5-number summary. The 5-number summary is the lowest value in your data set and the highest value. And then we also have Q1, which is the first quartile, remember the 25th percentile, the median, which is the second quartile or the 50th percentile, and Q3, which is the 75th percentile. This is called the 5-number summary. Now we can get it based on what we just did with percentiles, but I'm also going to show you how to get this directly from the calculator. Okay? So let's go ahead and put this data in our calculator. So if you have your calculator handy, maybe get it out with me and go ahead and put this data in. I'm going to kind of shift this aside here so you can see my calculator. Okay, so remember my favorite button, Stat and Edit. I referred to this before for you guys. So we're going to go ahead and just type our data in here. 89, enter. 90, enter. 86, enter. 96, enter. 84, enter. 100, enter. 85, enter. 96, enter. 88, enter, and 89. Okay, so we have 10 data values here, and they are not in order. So remember I told you before how to do it? I want to show you how to do this. So I'm going to do second quit. I'm going to go to Stat again, and this time I'm going to sort them in ascending order. Ascending, A means ascending, smallest to largest. D would be largest to smallest. So let's go down and choose number 2, hit enter. And then you have to tell it which list to sort. So look above the 1, 2, and 3 key here. You'll see L1, L2, and L3. My list is in L1, so I do second, number 1, and I'll put L1 in there. And if you hit enter, your calculator just says done. Okay, it doesn't tell you anything. So when you go back in and you hit stat, edit, you'll see that it put your data in order from smallest to largest. So now we can see our smallest data value is 84, the largest is 100. The median would be halfway between, so we do 0.5 times 11, so we'd have 1, 2, 3, 4, 5 data values here, and 1, 2, 3, 4, 5 here. So it's in between 89 and 89, which is just 89, so that's our median. So another way you can do the median is you find the middle data value, and then to find Q1, you find the middle data value of these lower 5 numbers, and that would be 86. And then the Q3 is the middle data value of these upper 5 numbers. And whenever you have an odd number, you know the middle number is that, so it's 96. Does that make sense? A little different way of just getting the Q1 and Q3. Okay, so the other thing we can do, which is kind of handy here, we're going to do second quit. We're going to go stat, and this time we're going to go over to calc. Now this is going to be important. And one of our stats we're going to use a lot in the next 2 sections. It'll show us the mean and standard deviation, but for now, just hit enter. We're going to leave the frequency blank, and we're just going to hit calculate. Now see this little arrow? It means you can arrow down. So I'm going to arrow all the way down. And it gives us lots of information here, and we'll talk about this in the next couple sections, but if you arrow all the way down, the last 5 numbers are the 5-number summary. And we got this already, the 84, 86, 89, 96, and 100. That make sense? Okay, so my 5-number summary is 84, 86, lost my calculator here, 89, 96, and 100. Okay, that's my 5-number summary. So the way we do a box and whisker plot is we have to have a scale. Okay, so make sure you have a scale that goes for the range of, you have a number line, and I'm just going to start with 80 here. 85, 90, 95, 100. And I'm going to plot these 5 points. So 84 is right here, 86 right here, 89 is right here, 96, and 100. Okay, so the box goes around Q1 and Q3. So this is my min, this is Q1, this is my medium, this is Q3, and this is my max. So Q1 and Q3 are my box, and then we draw a line straight through the median at 89, and then we draw these lines that are called whiskers out to the min and max. This is called a box and whisker plot. Basically what this shows you is the distribution of your middle 50% of your data as well as the tails. So looking at this box, the middle 50% of the data, if there's more space on the right, it means the middle 50% of the data is right skewed. If your median was right in the middle, it means it's symmetrical. If there was more space on the left, it would be left skewed. This one is a little bit right skewed. Also, it tells us that outside of our data, if the line is longer here, is a little more right skewed. Now, if you see some box plots that have dots on them, that just means they're showing you potential outliers. Now, our calculator also will show us a box and whisker plot. And one thing we can do is we go to second, stat plot. See stat plot up here? We hit enter. We need to hit enter here to turn it on. And you can see down here we could also do histograms here. So I'm going to arrow over to a box plot. This one would show me potential outliers. I'm going to choose this one. Oops, I forgot to hit enter. I got to go back up there, go over, hit enter when my cursor's over that. Now here's the key is we do need to hit zoom and go all the way down to zoom stat so the calculator will adjust the scale. And there's our box plot we just graphed. Now, if you wanted to hit trace, this button right here, you can see it'll tell you the 5-number summary, and you can arrow back and forth on your box plot to see that 5-number summary. Okay? Oops, sorry about that.